So boys and girls, question 8, we have a rod of length L and cross-sectional area A extended by E. So if capital E is referred to the Young modulus for the material of the rod and the change in the cross-sectional area is negligible, what is the energy per unit volume stored in the rod in terms of Young modulus E, extension E, and also the original length L. So I visualize the problem. So the length of the rod is L, the cross-sectional area is A, and this, when we apply a force, for example a tensile force, then there will be a elongations or the extension for the rod. So the extension of the rod is given by small capital E. So this material have Young modulus. But in this question, the symbol for Young modulus is given in capital E. So the question asks us to determine the energy per unit volume. So the energy per unit volume. Energy, strain energy is U per unit volume. Volume is capital V. So U over V in terms of E, Young modulus, extension E, and also original length L. So we know that the basic equation for energy per unit volume is half stress multiplied strain. So because I want to put it in terms of Young modulus, so I can try to relate the Young modulus with stress and strain. So we know that the Young modulus is stress over strain. So if I rearrange, so the stress might be the Young modulus multiplied with strain. So I put it into the equations. So the energy per unit volume for the question will be half. Stress will be the Young modulus multiplied strain and then multiplied strain again. So I'm going to have half E strain squared. Okay, strain squared. But then I need to put in terms of extension and also the length. So I'll try to relate the strain with the extension and also the original length. Okay, so we know that strain is extension over original length. So the original length in this question is using symbol L. Okay, so I put it in half E. So the strain will be extension over original length squared. Then you see we have already put it in terms of E, E, and L. We have put it in terms of E, E, and L. So our strain energy per unit volume will be half Young modulus extension squared over original length squared. So this one will be our answer. Okay. Now we move on to question 9. Question 9. Question 9, we have Young modulus. We are given the Young modulus of steel is greater than that of brass. So which would stretch more easily and which one is stiffer? So soalan bagi kita nilai Young modulus, dia nak tanya kita which material will be stretching more easily to be stretched, and which one will be stiffer. Stiffer means stronger lah. Stronger, able to resist to the forces. So we are given the Young modulus of steel is greater than Young modulus of brass. So how to answer the two questions? Anda kena faham lah. What is Young modulus? So if you recall the summary concept, what I have already explained, the Young modulus will indicate the stiffness of material. So larger the value of Young modulus, stiffer is the material. Our material will be stiffer. Stiffer means it will be stronger lah. It will be stronger, lebih kuat. So dia boleh resist kepada force yang lebih besar. So it will be difficult to stretch or compress. Why? Because it's stiffer. Dia adalah lebih kuat untuk resist kepada changes. So it's difficult to stretch or compress. It means that you need a larger force in order to stretching or compress the material. Okay, so since that our Young modulus for steel is greater than Young modulus for brass, okay, so it means that who will be stretched more easily? So brass will stretch more easily. Why? Because the value of Young modulus for brass is smaller. And then, which one is stiffer? Which one is stiffer? So, the steel will be stiffer. Why? Because the value of Young modulus for steel is greater. The value of Young modulus for steel is greater, so it's stiffer. So we have answer question 9. So we might pause the video to note down the answer. Now we move on to question 10. So question 10, we have figure 2. Show the variation of tensile force and the extension of a copper wire. Only you find out that this for figure 2, extension tu dia letak dekat paksi Y, force dia letak dekat paksi X. Okay, so we will get a straight line and then a curve. Okay, so you boleh terbalikkan. So you might ubah sikit graph tu, so straight line. If you find out, it's harder for you to get information from the graph lah, sebab dalam nota ataupun dalam summary video kita normally plot graph force against extension kan. So this is the graph lah. So state whether copper is ductile or brittle material. So kita nak tahu copper tu ductile or brittle material. Explain your answer. So if you recall to what we have already explained in the second video, we know that brittle material will fracture right after elastic deformation, but for ductile material, it will only fractures after it undergo elastic and plastic deformation. So for ductile material, they will undergo both elastic and plastic deformation. So we can apply this concept in order to answer the question lah. So for this question, we know that we are going to have the straight line portion is the elastic deformations and the curve part is the plastic deformations. So we know that this material undergoes both elastic and plastic deformations. So we know that copper is ductile material. Why? What is your reason for your answer? Because copper undergoes both elastic and plastic deformation. Sorry. Okay, so that one is our reasons. Alright, so we're done with question 10.